All right, so you have, we are here. We took the derivative. We got that. I'm starting back at the beginning. We're going to walk all the way through, okay? I took out the e to the negative x.
I have a question about that.
Yes.
Where did you get the 2 in front of the e?
Because e to the 2x, so it stays e to the 2x and then times the derivative of 2x, which is 2, from the chain rule. Yes.
Okay.
Yep. Okay, so we've got the derivative. We take out e to the negative x, right, because we want to factor something out there, right? And we have we don't want to deal with that negative x, okay? So that's why I took it out. So that's why it became 1. And again, since it's a minus x, I'm going to add 1 to my exponent instead of take 1 away like I normally would. Right, that part's tricky. Again, we determined that e to the x can't ever be 0, right? So if this whole derivative is going to be 0, like, because if you're multiplying things, right, one part of it would have to be equal to 0. It can't be that part, so it has to be this part. Okay?
I thought that also in these type of problems you can have the not equaling 0. It does not exist there.
You can, but that's not exactly, like, that's not what's happening here.
Okay.
Because it does exist, like, e to the negative x exists, it just... Yeah, that doesn't really apply here. Okay, so then we just know, like, we can factor it out. Like, that's still a valid part of our equation. We just are just worried about the other part. All right, so then we're setting that equal to 0. So I moved my 1 over. So that's where I have 2 e to the 3x equals 1. I divided by 2. So then I had, here, let me go over here. Okay, because I feel like this is where I lost some of you. So I had e to the 3x equals 1/2, right? So to get rid of, like, e to a power, like to get that 3x to not be an exponent anymore and come down, right, we want to do the opposite of e, which is ln. So you're going to take the natural log, or ln, of both sides of your equation, right? So, like, ln of that, ln of that.
And why the 1/2 again?
Because you have to do the same thing with both sides. I took my 1 and divided by 2 to get e to the 3x by itself. So that's where the 1/2 came from. Right, so then now I have, like, the ln and e cancel out. So now I have 3x equals ln of 1/2. They're opposites of each other. Because it's log base e is ln of e. It's like if you take the square root of something squared, that part cancels out. Same idea. They're inverses of one another. Okay, so now we're not quite done. All right, so we have to use what we remember about logarithms when they are divided. So ln of 1/2 is the same as ln of 1 minus ln of 2. Right? Okay. Anybody remember what ln of 1 is equal to?
1 over x.
Nope, not the derivative. That's not it.
Wait, I feel like I can get 0.
0. Right? Because anything to the 0 power is 1. That's why ln of 1 is 0.
I just heard you say that earlier. I didn't really know. Don't worry.
Well, now you know. All right, so then 3x equals negative ln 2.
Divide by 3.
Divide by 3.
X equals negative ln 2 over 3.
Yes, it does. So now, plug that in a calculator and get a decimal.
Okay.
But that's your one critical number.
You can't plug in ln in your calculator.
Yes, you can.
There's an ln behind.
So we only have one critical number.
Yes, one critical number.
You can have one critical number.
Mm-hmm.
Negative ln 2 over 3.
Put that ln of 2 in parentheses and then divide 3.
See, I have a feeling I'm
Yeah.
going to forget this when the problem comes around.
Oh, absolutely.
Again, these are a little bit more complicated. We're going to keep working, and it's been a while since we've done logarithms, so.
Can you tell me what it is?
Negative 0.231.
That's what I got. Negative what?
0.231. So then you could do, below that, you could put
What's negative 0.231?
It's a negative 1 and 0.
No.
Yeah.
I mean like for
I feel
for
like
the
you
left
could-
of that.
Oh, for the left of that, you could do -1.
I
Yeah.
thought you could do 0.
Yeah.
Yeah.
Wait.
And then you just use 1 and 0 to plug in.
Mm-hmm.
How do you -1 the x is on 0?
Hmm?
Calculator. How do you put it?
Yeah, the X. Oh, it's right here. Second ln.
What?
No, you can't use that calculator.
I mean, you can, but
I don't
where's
know how to
your...
do that calculator.
Yeah,
It's in my
Kate,
bag.
go get it.
It's in mom's room. Chicken bed.
It's 7th period. She's planning right now.
Wait, we're using it for the derivative.
Yes, so plug it in back to here.
I need to like highlight my derivative after I'm done.
That would be helpful.
Oh, my things are overcomplicated. I'm definitely plugging this in incorrectly. 14.4.
For your derivative. I think that's going to make it a lot easier. Well, that's not the derivative. This is before the derivative. So now I'm going to move my 3 in front, which cancels that. So that's your derivative.
Yeah,
That's not what I got at
that
all.
is not my derivative.
Don't you have to quotient rule or
No. It's just-
I quotient rule.
No, that's what I did.
If you do, then you have to cancel everything out and you should just get x. There's no variable on the bottom. It's just a number. So
You know, it did look odd.
Why? the
you
heck
should
is
end
it
up,
that-
do you have a bunch of 9s? Do you have a bunch of 9s? They'll cancel out and then you're just left with x squared.
I don't want to do that.
I have 1 9.
I got 9x squared. I got.
Yeah, I agree.
Hey, question. I don't even got. I'm
So you should get that for your derivative. That's going to make a big difference.
getting a positive and a positive. I hate myself.
Did you do 1/2?
No, just what?
From 0, all right.
I used -1 and 2.
I wouldn't use -1. All right, so look, at this point, guys, remember that it's not going to exist at 0, right? So technically 0 becomes one of your critical numbers. And you know that, like, nothing can happen over there.
Oh my gosh, that's what mine looks like. X squared.
How'd you,
Oh, wait, I
how'd
might
you get the
get
x squared? I'm confused on that part.
You're going to be multiplying
How'd you get x squared?
Because I thought of it as 1/3 x, so then you multiply 3 times a third, and then subtract 1.
Oh, and it gives you x squared.
Is 1/2 get you negative numbers that y equals 1?
Yeah.
Kaylee, sweetheart. So then I plug with negative.
Yeah, so I would plug in 1/2 and 2.
-1 and 2. How'd you get rid of your 3?
Well, the cube root
Yeah, okay.
of 1 is 1.
Because I got cube root, don't I?
All right, guys, finish through 9. Try your best. I think you got it.
I always
We
give
have till Monday, though,
110%.
so we...
You have till Monday. But we don't have class tomorrow.
So, where'd you get your 0?
Yeah.
So, it can't exist at 0, right? Because you can't have a 0 in the denominator. X can't be 0, right? So that's why I have a 0. And also anything with ln, like, it's not going to be negative. Like, so nothing's happening over here. That one's kind of tricky to know.
Increasing and 1 decreasing?
1 of each?
No, I got 2 of each.
No.
Is the first one not negative infinity to 0 and then 1 to positive?
No, you can't have negative infinity. Nothing's happening over there. So it's just 0 to 1.
0 to 1 for decreasing.
And then 1 to infinity for increasing.
Why do you have to do negative infinity to 0?
Because your function doesn't exist when you have negatives, because you can't have a negative ln. Like, you can't take ln of a negative number.
So we don't put it.
Right.
Oh my gosh, negative, positive.
Is it negative positive?
I was typing on this in.
Yes.
Did it die?
Negative positive.
Wait, this one. My brain can't handle the
Oh, if you
animals.
did that,
I don't
already.
understand.
Hey, Missy.
All right, so
Why do you not have negative 1?
natural log can't be negative, right? We can't plug in a negative number for x. So there's nothing that can be happening over here. This function is going to start at 0.
So it doesn't start at negative infinity.
Correct.
Okay.
So you're just going to go, if you're only, so you are decreasing from 0 to 1 and increasing from 1 to infinity. Yes, there is no negative infinity here.
Decrease from 0 to 1.
Yes.
Increase from
Yeah, find the dumb.
Number line.
Number line.
You'll get the hang of it.
It's the.
Hey, I'm sorry.
It's actually finding the numbers for the timeline that's getting me.
Yeah, that's what mine is.
Because there's always something different you can do.
It's
It's
like you
crazy.
send it to zeros, cube root square times multiply.
Take 2 seconds to see if you can find a number. Me and Christian are stuck on this.
Who's calculator?
For 3x of 2/3 equals 0. And then I was trying to set it equal to 0 and I couldn't. So then I just said x is not equal 0. And then I used 0 as my critical.
I got D and E at.
Okay, so let's determine. Yes, it doesn't exist at 0. That is correct.
So I just had 0 as a critical number.
Yes, that's right.
That's the only critical number I had.
Yes.
I had 0. I was right.
Yes, and did you get it increasing on both sides?
Yeah.
Yes, you should have.
Oh, sorry.
Okay, so let's go through it. Okay, so
Stared at that thing for
all right. Well, let's do the derivative because everybody may not have gotten it, and that's okay.
I got to where
So,
Kate told me that 0 was the only critical number.
so then you have 1/3 x to the negative 2/3 is your f prime.
See, this is where I get confused.
Okay, so then basically we know that x can't be 0, right? Because we can't have 0 in the denominator of a fraction, right? Can't divide by 0. So that's why our only critical number is, right, it's because it does not exist at 0. So then, and then when you plug in like -1 and 1, they should both be increasing.
So you just write negative in front of the positive in the room?
So, yes, so it's increasing.
I got something wrong here. I thought it was decreasing from -1. For some reason, I got decreasing.
How did you plug it in? Did you put parentheses around your x?
Probably.
Right, so this means there is no extrema, right? If it's increasing the whole time, there's no max or min. Okay? We good?
See, I thought that one was too easy. Like, why would 0 only be it?
That happens sometimes. It's okay.
When does 0 not exist? So,
What?
I don't know. Why does it not exist? I mean, I get it, but like, where do we get 0?
Right. So, when you're finding critical numbers, you either have to set the derivative equal to 0,
Yeah.
or when it cannot exist. So, if you have a fraction, that means you want to set the denominator equal to 0, which is technically what I would have done here. But if that's 0, then x has to be 0, right? That's the only way it can be 0 is if x is 0. It's kind of common sense at this point. Right, so then that's why it's 0 there. Right, if it's a little more complicated, then yes, you can set it to 0, which we'll do in the next one.
Did you set both the top and the bottom to 0?
Yeah.
Okay, I did that part.
Okay, see? I feel like you guys are doing better than you think. All right, let's make sure we got our derivative right.
Really putting stuff on my back.
It's a little gross, but that's okay. All right, so we have to do the quotient rule. Okay, so did we end up with...
Wait, yes. But then I took out an x.
No, you can't do that.
Are you
I
serious?
mean, I
an
took
x.
out next, factored out next.
Like, took
On
it-
top?
Yeah.
And left it on top? I mean, I guess you can, but I don't know why you would.
Just to solve the top with 0.
Oh, okay, yeah. But that should be your derivative.
I don't even take a derivative anymore.
Do,
No, like, I
do you need me to go through it?
I know it's the bottom times the derivative of the top minus the top times the derivative of the bottom.
Yes. But did we mess up somewhere? Maybe? All right, let's do it. Okay, so the bottom times the derivative of the top minus the top times the derivative of the bottom. So then you get 2x squared plus 2x minus x squared.
Wait, where did you get the plus 2x?
Distribute that. Do you forget to distribute?
Wait, what happened to you? Yeah, I only distributed it to x.
Yeah, gotta do it to both parts. Hey, it's okay. At least there's been worse mistakes to make. You remembered how to do the derivative. We just made a mistake in simplifying, and it happens sometimes, and that's okay.
We're all in this together.
Okay, no.
That is not where we went on with that.
All right, so then, so critical number. So we're going to set the top equal to 0. Okay, because that's when that derivative would equal 0, right? Is if the top is 0. So then, yes, this is where you would factor it out, yes. So then x can be 0 and negative 2.
Where did you go?
Because that you have to set that factor equal to 0.
I thought it's 0, but I also don't
Do y'all
Where did it
play
go?
Thursday?
For the top, how'd you get a 1?
know. What?
How'd you get a 1?
Well, I didn't derivative right.
Oh, that would make sense. Okay. And then on the bottom, right, we're going to set that equal to 0 as well. And why are we setting that one equal to 0? Right, because it can't be that, right? So again, this one is for when it equals 0.
Oh, wait.
And this one is when it does not exist.
Oh, should I just look at this for a second?
Yeah.
Because I thought I was something wrong.
Where did the no? This is like I'm a little behind, so don't like hate on me for real. But
Since when have I hated on
I
you for?
don't know. I just got a lot of haters out there. So where did the 2x squared go?
I subtracted the 1x squared.
However, you still have an x squared there.
Right, because 2x squared minus 1x squared is 1x squared.
So you can take.
Oh,
Okay.
okay.
You could technically have 3 things on your timeline.
Yes, you can have as many as you want. And it's a number line, not a timeline. This is not history class.
It takes time to draw a line, therefore.
Isaac, hush.
Wait, why is your x plus 1 not squared?
Well, okay. I mean, it is, but then you, oh no, take the square root of 0 and get 0. It doesn't matter. It's
But you have
irrelevant.
x equals -1.
Right. So that's another critical number.
And then you square root the 1 and 1.
Well, you square root first and then subtract.
Oh, you square root first?
If it's in parentheses like that, yeah.
Petition to kick Isaac out of the classroom.
No.
Okay, I'm sorry.
Okay, okay.
Whoa, what am I doing?
Wait,
You're doing math.
Sure.
Which numbers?
You have to also set the bottom equal to 0 because then the derivative can't exist if the denominator is 0. And we can ignore the squared because it doesn't matter.
Can you? Okay, you can obviously do math with letters, but can you do math with like Greek letters since there is Greek letters?
We do it all the time.
No, but like actually,
Theta.
like I know, but like
Alpha,
actually,
beta.
like,
Sure, it doesn't matter.
make a big
You could
old-
put shapes in there if you wanted. I don't care. Not the time for that right now.
It's just placeholder.
Guys, shh,
Okay.
exactly.
I know we just talked about this. Why does it does not exist?
Because the bottom can't be 0. You can't divide by 0. So if I plug in -1 for x, I would get 0 on the bottom. Okay, those are your critical numbers. When you test them, you should get a positive, a negative, and a positive.
Dang it. I got a positive, negative.
Well, I got something, but I forgot that the 0 existed. So
Yeah. I got the -1 and 2, and I. Because
So you probably have positive, negative, negative.
I've been saying that.
I got positive, negative,
For
positive.
real.
Because I instead of
I
because
used -1.5, -3, -1.
I used the
Mm,
0
okay,
as
that's
the
why.
number
I
because
messed up.
Oh,
the
okay,
zeros.
okay.
It's
Yeah,
just
so
my
that's
fault.
why. Yep. Okay, but not a big deal.
No.
All right.
Don't.
So again, we are.
I was just about to do that. Oh, I forget there's more every time.
And we are decreasing from -2 to 0. Sorry, no, we're not. And -1 to 0. Because our function doesn't exist at -1. Or our derivative doesn't, so we can't say anything's happening there. Well, our function doesn't exist there either.
I just about put -0.
It's fine.
So when it doesn't exist as a number,
You have to stop.
you have to stop and start.
hmm
Wait, what?
So like for the
that means there's, like,
decreasing,
an open circle there or something?
yes. Because look, if I plug in -1 for x, nothing, it can't exist. It doesn't work. So like you can't have it or decreasing through -1 because nothing's happening at -1.
So when there's like back like positive, that's an open point?
If it's a does not exist in between them, yes. We got 1 from where our derivative does not exist. So that's how that came to be. So that's why we had to do that. If it was a 0, it wouldn't matter.
See, once I found out there was a D and E, I would have just stopped.
No.
I don't know how you knew that was D and E.
I set the denominator equal to 0. You can't divide by 0. That's when things do not exist.
When things turn for the worst right
That's the whole reason we found that number.
there. Gosh.
You have to do that when you have fractions or square roots.
Why is that on your number line?
Because critical numbers are when the derivative either does not exist or if it's 0, because those are the places that maxes and mins can occur. So you have to think about when the derivative is equal to 0. You have to think about when the derivative would not exist. Okay, in this particular case, right, our derivative would not exist if x was -1. Because then you're dividing by 0, which you cannot do. Which is why I set it to 0 to figure out that it is in fact -1 that I cannot plug in.
When you have a fraction, you're always gonna have one that does not.
Yes, if you and like if there's variables on the top and bottom, yes, or on the bottom. Okay, if it was just like 1/2 x, like no, because that's just 1/2 times x,
And you
right,
always put it in the middle?
or wherever it goes.
Where'd you learn how to math so good?
Concord.
She taught herself.
You
Also some of that, yeah. All right, let's do number 9. Okay, so we have to do the product rule.
Yeah.
So we have to do the first times the derivative of the second plus the second times the derivative of the first. Okay, so we have that. So then we can,
Oh, mine are up backwards.
I did them backwards.
okay, it doesn't matter.
Okay.
You're just adding, it's the same thing.
Wait, isn't it a 1? Oh, never mind.
Yeah, because it like the times. Yeah, you s-
I forgot you skipped the whole step.
How did I skip a whole step?
Well, you see, I like visualization, and I make.
I mean, I do
X a
too.
1.
You guys
Oh,
look like calculus and hard.
all right, so then now I'm going to factor out an e to the x.
You have to distribute that e to the x though?
I mean, you can and then do it, but if I'm just taking it away from that, that leaves me with the x minus 2 and then a plus 1.
Whoa. I did +1.
Oh, I didn't leave something.
I took the e to the x out, so I have to leave a placeholder.
I'm a dummy.
Oh.
Things don't just disappear.
I don't know. If you would have distributed that e to the x, would it have been x e to the x?
hmm So, yeah, you can do it that way. So you can have x e to the x minus 2 e to the x plus e to the x. And then if you take it out, you have x minus 2 plus 1. So you get the same thing.
Yeah, that makes more sense.
-2 plus 1 is -1. That's fine. If you want to do it that way, Kaylee, that works. It is, but if it helps you visualize it better, then that's fine.
If we would have left the 2, would it have come out differently?
Left the 2.
I mean, like I know we shouldn't have, but I did not catch that. And I don't know that I realized.
Well, we need to. Yeah, it's not right if there's a 2. It's a -1. All right, so then we set that equal to, so that's our derivative, right? Wait, what does that look like? Ooh, nope. Too skinny. Oh, that's like pencil-y. I don't like that. I don't.
These are so small.
I don't know. Why is it not doing anything? What is it? Why are you
You gotta get rid of those.
being mouthy?
I was kinda like
I don't care. All right, so then set it equal to 0. Oh,
okay.
Little dirty dots.
oh my gosh, Kate.
I hate
I can't get it to go away, so just don't look at it.
Seriously, like a sparkly, really dark, deep purple.
Okay, focus.
They both got the same problem.
Is one of our critical numbers 0 and the other one -1?
Do you guys actually?
No.
Oh,
I've been planning to wear light blue for a senior prom since I was.
I got the exact dress since last
They got the same
But
problem.
I know I wanted light blue for.
They're fighting
But
away
did you
for
have
years
the
in US.
exact?
okay, moving on. So we know that u to the x can't ever equal 0, right? So then that means we just have to set x minus, no. It's not that it doesn't exist, it's just like we can't use it. So we know that if we multiply these things together, the only way it's going to equal 0 is if this part equals 0. Okay, if you multiply two things together, right, and get 0, that means one of them has to be 0, right? This can't be 0. So to get 0, it has to be this. Yes.
Okay, for one above this, you put what's outside of the parenthesis equal to 0 and then what's inside the parenthesis equal to 0.
Right.
Not both. Not like,
That is both.
no. You see e to the x, and it would be like e to the x equals 0 and then below that x minus 1 equals 0.
I mean, okay, you can do that, but this is not possible.
Yeah, so 0 is not actually a critical number.
I thought we
Right.
just said that's what it, because it could.
Okay, because I put 0 as a
Yes.
critical number because I said it couldn't exist there. But it
No, like it can't. Like it's just e to the x, but that doesn't mean our derivative can't exist there.
So we know that.
Like e to the x part of our derivative can't be 0, but the other part can, and that's fine.
So
It's all good. It's not that it doesn't exist, it just means that that particular part will not be the 0 part.
It's not possible.
So why isn't that a critical number then?
Because it doesn't, just because e to the x can't equal 0 doesn't mean that, all right, guys, let me finish my explanation before we interrupt, okay? We're looking at the whole derivative, okay? Just because one particular piece of it cannot be equal to 0, that doesn't mean that the whole derivative wouldn't exist. There's just no number that we can plug in for that x that's going to give us 0.
Why can't,
Like, so it can be lots of things, huh?
why can't e to the x be 0?
Well, e to the 0 is 1.
Isn't it actually? Yeah.
Yeah, e to the 1 is just e. E to the -1 is 1 over e. Like, there's no way we can get a 0 out of that. It is not mathematically possible. It doesn't. But that doesn't mean it doesn't exist. Like, e to the x is still a function that still works. It's just not ever 0. Okay? But we're saying that this whole thing is going to be equal to 0. So we want to figure out when this is 0. Obviously, this part of it can't be 0. So this part of it has to be the part that's equal to 0. Okay? We're not breaking any rules by saying this isn't 0.
I just thought that on the other ones we've taken both parts and set them to 0.
Well, we have, but you can't set e to the x equal to 0 and get an answer. It's just that part doesn't work.
That's why.
Right, but that doesn't make it a critical number either.
You know what I was doing? I was just.
Because you're still allowed to plug in 0 for x and get a valid answer.
Okay, that makes sense.
Okay.
I was
Guys,
thinking you were
guys.
saying
Shh,
that
Dylan,
the
hush.
X in the parentheses was 0 and not the whole parenthesis. So like I was getting -1 instead of putting in a 1 and then getting 0. Like I was doing it wrong.
Okay.
But like now I realized that I was.
Okay, that's all that matters. All right, so that's why 0 is not a critical number. Does that make sense?
That makes sense.
Okay, great. Love to hear it. Right, so then our critical number is 1.
Yes. Well,
Negative, positive. So we're increasing From negative and, just kidding. From 1 to infinity. And then we're decreasing from negative infinity to 1.
It makes so much more sense when you work them out. I don't know, like,
You'll get there.
Like, I would never do some of these things every day.
Okay, but we should be. Right? We're at the point where I'm expecting you guys to be able to do these things.
Are we gonna be doing calculus until like the last day?
Yes.
When is our last day? Like,
I don't know, but man, we do not stop.
Well, I'm just thinking, spring break and this, like, there's only so many days left.
Right, and we will use every single one of them to do calculus. I don't do free time, sorry. I'm here to teach you calculus. Same with physics. It goes all the way to the
I
end.
don't care about physics, it's this.
Bro, this
You'll be okay. All right, so let's go over that PowerPoint you guys did yesterday.